All right, welcome. Math 123, Tuesdays, 8 to 9 p.m. This is March 19th. And so I just want to get started here by reminding you of some things that are due and some things coming up. So we have WebWork 9 and an Excel models and let's see, exponential models, I guess that would be. And we have quiz 4 all due tomorrow. I don't know. Did you guys notice the Excel exponential models assignment? Was that actually in there? I have it on the syllabus, but I didn't see it. Okay, excellent. All right, so I graded the I graded the trend lines assignment, and overall it went pretty well. The only thing is you guys need to make sure you read the instructions because some of you just listed answers in each piece, and it asks you to write a 2-paragraph response to the questions, not just writing your answers inside those blanks with the question. So make sure you read the directions. I think on this one we have today with credit cards, I think that one you can just answer the questions in line. So the credit card, we have an assignment today. It's called Excel Credit Cards Assignment, and it says to create a spreadsheet using formulas. That's the whole key here, using formulas, right? And let me update my attendance here. And then this one is just write the answers in, okay? You don't need to, it says you will need to submit both your Excel spreadsheet and a Word document with the answers to the questions in order to receive full credit. So the Excel spreadsheet is going to be separate. And then you can just submit this document with your answers, fill your answers in there, okay? You might want to, maybe you can boldface them or something so I know that that's your answer, or type them in a different color or something, but note somehow that these are your answers in here where it starts, okay? And then make sure that your explanation here for part E is, it's meaningful and not super simplistic. All right, so that's that assignment. And then, so today, our assignments are WebWork 10 and 11, and then that Excel credit cards. And I hope you guys had a great spring break and it was relaxing and you had your work done ahead of time so you weren't rushing to get things done, or maybe you spent some time working ahead. That would have been awesome if you did that. I think some of you did, so great job. Midterm grades are all submitted and reported. So yeah, so I want to make sure you know that on page 235 and 236, that's a copy of your reference sheet. And so on exam 2 and exam 3, your testing center will provide that for you. So you'll have a copy of that to use. And we're looking really today at page 236, kind of towards the middle-ish. All right, and we're going to start with section 10. Section 10 talks about credit cards, and section 11 talks about loans and mortgages. And so the mortgages piece for section 11 is really big because that's part of what your next project is going to be about. And so you want to make sure you get any questions answered that you have on that piece for sure, okay? All right. So it says here, we're looking at page 130 to start. And it says a credit card allows an individual to borrow money on a short-term basis to pay for goods and services with the promise of payment in the future. Credit cards afford individuals a great deal of convenience by removing the need to carry cash for purchases and providing an opportunity to establish a favorable credit history. So it says, let's consider a finance charge on a credit card with a balance of $1,000 in an APR. APR stands for annual percentage rate. Annual means yearly, of 16.99%. Credit card companies are only allowed to charge the user interest for the period of time that the money is borrowed. They compute the finance charge based on a daily interest rate, which is the APR divided by 365, for the number of days that the money is in use. However, to simplify our calculations, we will use the monthly interest rate, which is the APR divided by 12. So it says here's a note. The lender will not charge a finance charge if the entire balance of the credit card is paid before the monthly due date. So if you buy something for $25 and you pay that balance, so you buy something for $25 and then the credit card company sends you your bill. If you pay the $25 before your bill is due, by the due date, there's no interest on it. However, if you don't pay the whole amount, then the interest starts to get accumulated. So it says here, in addition, almost all credit cards have a grace period in which no interest is charged between the purchase date of the item and when the bill is received. So I don't want to really concern us with this part right here. I'm not too concerned with what the monthly interest rate is. You might have to make that calculation, but all you do is take the APR as a decimal and divide it by 12, because we're just going to put that right in our calculation. So it says here, make sure you convert the percentage to a decimal, okay, when you do these. So the finance charge for owing $1,000 for a whole month is the monthly interest rate times the balance. So the monthly interest rate, what you should probably do on your calculator is not do the monthly interest rate separate, just do it all together. So on your calculator, you would do something like 0.1699. Whoa, my mouse is going crazy and writing huge today. Divided by 12, and then times the $1,000. And then you don't get hung up with rounding errors. So it says, use this information to think through 3 more examples. So number 3, on the bottom of page 130, says, calculate the finance charge for a carryover balance of $1,650 with an APR of 23.99%. So what we would do is we'd say finance charge equals, let me try this right again, equals, and we're going to do 0.2399 divided by 12 times $1,650. And let's see, putting that in my calculator, I got $32. Wow, that was a big decimal, wasn't it? And 99 cents. So what I want you to do is I want you just to take a second and do number 4 and 5. I'll give you a minute to do that, okay? When you have number 4 and 5 done, go ahead and put a hand raise in the chat box. All right, well, it looks like most everybody is done. Now, before I do those, I want to show you that this is really the same thing we did in the past. So do you remember the simple interest that we calculated? We did the interest, we said, let me try that again. We said the interest equals the principal times the rate times the time. That's exactly what this is. So if you look at the example I already did, it's the principal, 1650, times the rate, which was 0.2399. And then remember, for that interest that we calculated earlier, the time was years. So this is 1/12 of a year. And if you put these two together, that's the same as that right there. So it's really the same thing we did when we calculated simple interest. So here you should have done the 0.1599 divided by 12, and then times 1650. And Estefani says it is $21.99, and I agree. You guys get $21.99? Perfect. All right. So it says, what difference did the lower APR make in the finance charge? So mathematically, it's $11, right? My gosh, I'm having a really difficult time with my math here. I got a new mouse because my other one was falling apart. And I can adjust the speed on it, so that's better. Okay, so let's try this again. So I'm going to try and write better with my mouse. $11. So the lower APR resulted in a decrease in the finance charge by $11. You could say that in a sentence. All right, so the difference. So the lower APR decreased the finance charge by $11. Okay, good. So let me put your hand raises down. All right, so let's go on to page 131. So on page 131, wait, maybe this isn't page 131. Where is that? Oh, it's on the bottom of page 131. Okay, so on the bottom of page 131, that's a lot of reading there, but let's just check it. I'll read it really fast. If every credit card user paid his or her balance completely every month, there would be no finance charges owed to the lenders. Credit card companies are in business to make money, so there are a variety of other fees associated with the use of credit cards. If the lender does not receive the monthly payment by the due date, there would likely be a late payment fee of $15 to $39, and your APR may increase dramatically. The late fee is inconvenient, but an increase in the APR has a bigger impact in the long run. Having your APR permanently increased to as much as 29.99% for making a single late payment is not unusual. Any payment received by the lender after the due date is considered a late payment. If mailing a payment, it is extremely important to allow extra time for it to reach the lender. It's also possible to incur additional fees by exceeding the credit limit of the credit card, the maximum allowed balance. Many credit cards are initially issued with low credit limits, typically $300 to $500, in the hope that inexperienced card users will exceed their limit. This generates additional income for the lender. The over-the-limit fee can be an additional $15 to $39 charge and may also result in an increase of the APR. Failure to make at least a minimum monthly payment could also result in similar fees and penalties. It's extremely important to read all of the fine print on the original credit card application and any subsequent materials that the credit card company sends. All right, so on the next page, what we're going to do is we're going to look at this sample agreement and then answer some questions regarding it. So the annual APR, the annual percentage rate, the APR is 15.99%. It says there's a penalty depending on your credit worthiness. If you make late payments, they can exceed the credit limit, or they can change the wait, it's the one with the tail. Yeah. So page 132. So it says there's a late payment fee of $35, return payment fee of $25, over the limit fee of $39, cash back rewards. Oh, this is the good stuff. So it says you can earn a full 1% on all purchases after your total purchases exceed $3,000. Purchases, exactly. Purchases that are paid, or excuse me, purchases that are part of your first $1,500 earn a whole whopping 0.25%. And purchases that are part of your second $1,500 earn an additional whopping 0.5%. The credit limit is $500, and the minimum monthly payment is $20 or 5% of your new balance, whichever is greater. So let's look at Jennifer here. Suppose Jennifer has a new credit card with the above rules. Her credit limit is $500. She purchases $195 in school supplies at the beginning of the month. Jennifer pays only the minimum payment the month of the purchase, so it says no finance charge in month 0. What was her minimum payment? Well, if she purchased $195 in goods, we would take that times 5%, 0.05, and see how much that is. That looks like $9.75. And the minimum payment here is $20 or 5%, whichever is greater. So it is $20. So her minimum payment is going to be $20 because it's whichever is greater. So it says, what is her carryover balance? Well, she has $195 and she makes a $20 payment. Her carryover balance is $175 because she didn't get any interest on the first month that she made those purchases. So now we're going to look and see what happens as we move along. So there's our carryover balance for Jennifer, $175. So now in month 1, so she bought this stuff, she got her billing statement, and now we're starting month 1. So once she gets that billing statement, her due date passes, now interest starts to accumulate. So what's what the monthly finance charge is going to be? So she's at 15.99%, so 1,599 divided by 12 times the $175 that she had carried over. In the finance charge there, $2.33, just like some of you had up in the chat box. $2.33. And let's see, she doesn't make any additional purchases. There's no additional fees. So her new balance is $177.33. We just added the carryover balance and the interest finance charge. $177.33. And now we're going to find the minimum payment. So $177.33 times 0.05. So we're going to check that, or $20, and that is $8.87. So the minimum is going to be the $20. So the ending balance, or the carryover to month 2, is going to be $177.33 minus that minimum payment. So $157.33. So the math on that, $177.33 minus $20 is $157.33. All right, so that's the bottom of page 132. So at the top of page 133, it continues, and it says, what will Jennifer's cashback reward actually be for the school supplies? Well, let's check. Her school supplies cost her $195. Now, the cashback rewards, if you look over on page 132, it says point on the first $1,500. So 0.25%, remember, to change that percent to the actual decimal equivalent, we have to move the decimal 2 to the left, so it's 0.0025 when we do the multiplying. And so, Kinder, you got to put 2 zeros in front of that 2. All right. So let's see, 195 times 0.0025 is 0.4875. So 49 cents. All right, so notice she bought $195 worth of stuff. She paid $2.33 in finance charges and got 49 cents back for her cashback rewards. So she's actually negative because her interest was more than her cashback rewards were. My oldest son is 16 now, but when he was 3, he would call that a gimmick. I had him trained young that when he went to McDonald's, he didn't get a Happy Meal because the toy was a Happy Meal gimmick. So he was never into Happy Meal toys because they were gimmicks. All right. So cashback rewards for purchases are calculated only on new purchases. A balance from a previous month is not subject to cashback reward. If consumers fail to collect their earned rewards, there are increased profits for the credit card companies. So here it says, assume that Jennifer is so excited by the prospect of a cash reward that she purchases a $400 plane ticket to go to Cancun for spring break. What will Jennifer's cashback reward be for the plane ticket? So we're still under that first $1,500, right? So 400 times 0.0025 is $1, just like you guys are noting in the chat box. Excellent. So she was super excited. She's going to get that cashback reward of $1, and she still hasn't even caught up with the interest of the fees that she's paid for her finance charge. Jennifer has now exceeded her credit limit. Well, because her credit limit was $500, right? So it says the credit card company can and does charge an over the limit fee and increases her APR to 29.99%. So we're going to update the table. So the carryover balance, remember, was $157.33. Well, she does now, right? Okay, so let's see. We have to calculate the interest on that. So we're doing 157.33 times that new APR, 0.2999, over 12. And we'll see what that finance charge is. So $3.93. Wait. Oh, wait, why? Okay, so Kim, you say $24.99 and Kaylee says $24.99. It should be $29.99. I think we're using. So Kinder, did you get that value with using $29.99? Oh, $29.99. Sorry about that. So 157.33 times 0.2999 divided by 12. 393. Yeah, okay. Good. So the finance charge is $393. She has her purchases, right, of $400 for that plane ticket. And then other fees, well, she went over the limit. So the over the limit fee is $39. And the new balance then is $600.26. So if you add all those up, you should get $600.26. So the minimum payment now, we have to do this, let's see, 600.26 times that 5%, and then we're going to check to see which is bigger, this number or the $20. And it looks like we're getting $30.01. So the minimum payment, $30.01. And then the ending balance, so we're going to subtract those. It looks like $570.25. Perfect. So hopefully you guys are getting that and following along, and that's making some sense. So tell me what questions you have at this point. Any questions at this point? Okay. Remember, if you have questions, you need to ask. The only bad question is the one that's not asked, okay? How cliche is that? Spoken from a truly seasoned teacher. Oh, I've got to tell you this quick story. So I went to McDonald's today in the town that I started teaching in, and this guy walked up to me, this big burly guy, big long ZZ Top beard. He goes, "Hey, Mr. Flutes, do you remember me?" And I was like, I don't know. He goes, "You don't remember my name?" And I haven't taught in that town in like, I don't know, 15 years. And I was like, "Hang on, let me cover up the beard and see if I can tell who you are." He was like, "No, you got to help me out." And he told me his name. And he said, "I had to come over and tell you hi because you were always my favorite teacher." I was like, "Aw, you're so cute." And he's like probably 35 years old. But so that was my good story for the day. I love when that happens. It's like, "Oh, thank you so much. I appreciate that." But anyway, it keeps me smiling. So it says here, since credit cards all require a minimum payment by the due date each month, let's explore what happens to the balance if only the minimum payment is made each month. Okay, so we're going to look at this 22.99% APR and a minimum payment of 3% and see what happens with this carryover balance of $3,000. So the finance charge, we're going to check this out. So the finance charge is $3,000, and then we have this 0.2299 divided by 12. Yeah, I hope that I made an impact. That's always my goal, is to, just like in this class, even though I don't get to meet you all, I really enjoy it. I hope you can tell I enjoy this, and I'm smiling nearly the whole entire time that I'm with you. But my whole goal is that you guys at least get a smile out of class, and you feel like you learned something when this is all said and done, and that you appreciate math. And it's not like, if when I teach in the classroom at the college, I always ask my students, "How many of you hate math?" And nearly everybody puts their hands up. I'm like, "Great." How many of you had success in math? And maybe half their hands might go up. And so my goal here is that you do this math and you have a greater confidence than you did when you came in, and that you feel like you had some success here, and you can appreciate math a little bit more than you did in the past, and that this class was a good experience for you. So that's what I want to accomplish, and hopefully you smile at least one time while you're in this class with me. So the finance charge here is $57.48. And so that makes the new balance $3,057.48. All right, thanks, Kendra. So the minimum payment is going to be 3% of this, right? So 3,057.48 times 0.03. And looks like Kelsey has $91.72. And Kayla, so good, looks good, $91.72. So it says the minimum payment covers the finance charge. Anything left over reduces the balance. How much does the minimum payment reduce the balance? Well, let's see. I know this is kind of a crazy question to have in here, but we'll attempt it anyway. So the minimum payment is $91.72. The finance charge was $57.48, and so the difference is what the balance was actually decreased by, and it is $34.24. So it says, what is the beginning or carryover balance next month? So there's two ways we can do this. We can take that $3,000, or we can take the $3,000 and subtract $34.24, or we can just do what we've been doing, take that new balance and subtract the minimum payment, and that's what I'd recommend. So 3057.48 minus 91.72. And that is 29.65 and 76 cents, just like you all have. Perfect. So it says, what can you conclude so far about only making the minimum payment each month? it's a bad idea. Yeah, only a small amount, or there's only a small reduction in the balance. And it's going to take a long time to pay it off. Yeah, the finance charge was 57.48, and the principal applied was only 34.24. Yeah. So, but you reduced it a tiny bit. It's not that $3,000 anymore. It's only 29.65, right? So on the next page, it asks us to fill in this chart. And so what I'm going to do is I'm going to pull up Excel. I'm going to show you how to do it in Excel. So, oops, let me make sure I have all my details right. So month one, $3,000. Okay. So I'm going to try and do this quickly because I have limited time here. So the way I do my months is I do 1, and I do the next one as a formula, equals the previous one plus 1. And then I can just pull it down. Okay. Starting balance, $3,000. I'm going to just put all these as dollars. Okay, so $3,000. The finance charge, I'm going to put this as a formula. Oops, so the finance charge is equals, and this was, I got to go back here and look. So it was the 22.99. So, okay. Okay, so 22.99%. So it's going to be 0.2299 times, divided by 12 times, and then I'll put this number in here, the previous value. Okay, then the new balance as a formula is going to be equals this one plus the finance charge. The minimum payment is going to be equals the new balance times 3%. Then the next month starting balance is going to be a formula. It's going to be equals the previous new balance minus the minimum payment. And then what I can do, since I use formulas, is I can pull all these down and it fills in the table. Okay. I think it just wants us to go this far in that exercise. So when you can go back through and look at the video and look at the formulas that I put in and make sure they make sense, okay? But it's just doing the calculations we already did. It's just instead of using my calculator, I'm using Excel to do the calculations, just like we did in the book there, okay? All right. So that is section 10, credit cards. Okay, so I need one good question before we move on to section 11, because we're running out of time already. We're already halfway past our time. So give me a question. What is a question that you have about this so we can move on? Somebody ask a question. Come on, you can do it. Oh my gosh, you guys are either super smart and get it all, or you're too afraid to ask a question. Does an empty question count? I hope that you're not too afraid to ask a question. That would be terrible. I would feel terrible. Or do you just not have any questions? I mean, it's fine if you don't. Kendra says she's good. Stefani says he's good. Okay. I have to make sure. I don't, like I said, I don't want to. I teach teachers and I tell them, don't just ask, does anybody have any questions? And then everybody says no, and then you just move on. Ashley, sure. So we still had, because our assignments, because I give you so much time on the assignment deadlines were still as they were, so whatever we had due was still going to be due. All right, so they are pretty straightforward, I agree. Okay, so I was going to tell you that I teach teachers, and I always tell them, don't ask these yes no questions. Like, does anybody have questions? It's a yes or no. Everyone's going to say no, of course. So I catch myself doing that. So that's why I had to ask. I need one question. All right. Well, let's move along for the sake of time. On page 140, we're going to start talking about loans and mortgages in particular as we move forward. And I want to remind you that the mortgages piece here is a big part of your next project, so you don't want to miss this. And again, I want to remind you that these recordings are available in that whatever that YouTube channel that I put out there, okay? And the links are always in your announcements. So mortgage payments vary depending on the amount of the down payment. So a mortgage is like a loan for a house, okay? So it depends on the down payment, the interest rate of the loan, and the lifetime of the loan. Most mortgages are for 30 years, though 20-year and 15-year mortgages are options for some. For the examples in this book, we will assume that all loans are fixed rate and fully amortized over the given number of years. For example, a fully amortized 20-year fixed rate mortgage means that payments are always the same from month to month for those 20 years. And at the end of the 20 years, the loan will be paid completely. So remember when we looked at the credit card, the monthly payment changed every month, right? So when you amortize a loan, which is what we do for bigger loans generally, and what that does is it says, I'm going to make this payment. It's going to be the same payment every month. Part of it's going to be principal, some's going to be interest, and then in the beginning, it's more of it is interest. At the end, more of it is principal. So it says here, we're going to look at Roger. Roger has found a home to purchase for $115,900 and has agreed to pay 20% down. What will Roger's down payment be? So he's going to take that $115,900 and pay 20%, so 0.20. And the down payment is going to be $23,180. So he's going to pay that much up front, which means he won't have to borrow as much. So remember, this was the price of the house. He's going to put this much down on it. So the next question is, how much does he need to borrow? How much is the mortgage going to be? So it's going to be $115,900 minus the down payment. And it is $92,720. Just as you are putting in the chat box. Thank you. All of you who have done that. It looks like Kelly, Pamela, Kelsey, Kaylee, Kendra, and Carly. Thank you so much for getting those in there. So it says to calculate Roger's mortgage payment each month, we need to know the interest rate of the mortgage, how many years the mortgage is to be paid over, and how much is being borrowed. Roger's lender has given him an interest rate of 3.75% annually and expects his payment on the first of each month for the next 20 years. So there's a formula in Excel that will calculate this monthly payment, and it's called a PMT formula for payment. And it says we're going to use the monthly interest rate as a decimal, the number of payments, and the amount being borrowed. So I'm going to show you how we put this in for Roger. So let me increase my view here for you so you can see. Okay, so I'm going to just use this formula, PMT, and if you look at it, it should come up there. So right below where I type PMT in my parentheses, you can see rate, number of periods, and PVFV type. Okay, so we're going to put in the rate. So Roger's rate is 0.0375 divided by 12 because we want the monthly rate, comma, how many months? Let's see, how many months? He's going to do this for 20 years, so 20 times 12, or you can just put in what it is, 240, yeah. And then the amount he's borrowing now, since this is money he's giving away, we're going to put a negative sign in there. Negative 92,720. And when we put those in, this PMT, this payment, is going to pop out how much Roger needs to pay every month. So his mortgage payment is going to be $549.73. Now, I want to tell you that if you do this for a house that you're going to buy, that won't be your payment because you'll have probably taxes and insurance added into that. So that's just for the loan. That doesn't include taxes and insurance and all the other stuff that they put in there as an escrow. Okay. So let's see his monthly interest. So we can just fill this in if we want. 0.0375 divided by 12. That's the monthly interest rate. The number of payments is 240. And then there's our formula. Make sure you put the equal sign in there. So using Roger's monthly payment of $549.73, let's answer the next couple of questions. How much will Roger pay in mortgage payments over the 20-year loan? Well, we're going to take 12 times 20, the number of payments, or we can take 240 if you want, times that 549.73, and that's how much he'll have paid over that 20 years. And it looks like you guys are getting $131,935.20. So if he makes all of his payments over those 20 years, doesn't sell the house, he will have paid $131,935.20. How much will Roger pay in interest over the life of the loan? Well, all we do is take that amount that he paid and subtract the amount that he borrowed. So you got to be careful here, because it's not the amount of it's not the cost of the house, it's the amount that he borrowed. So minus the amount he borrowed, that was that 92,720. And so the amount of interest he pays over those 20 years is $39,215.20. And it asks us what the ratio is. What is the ratio of his interest to the total mortgage payment? So let's see. The interest, 39,215.20, to the total paid, 131,935.20. Now remember, look at this ratio. This ratio is a part to whole, isn't it? It's a part to whole, so we can actually note this as a percent, 0.297. So if we wanted to write this in a sentence, we could say that in 20 years of making payments, Roger would pay, or 29.7% of his payments would be towards interest after his 20 years. So putting that in a sentence, I'm not going to do that right here. Okay, so write that in. So because it's a part to whole, we can make this a percent and write a sentence about it. 29.7% in interest. So we could say 29.7% of all his payments went towards interest for those 20 years. So the next question says, what if Roger borrowed $92,720 for 1 month with an annual rate of 3.75%? How much would he have paid that month? And so let's see. So 92,720 times 0.0375 divided by 12. It is $289.75. Gosh, you guys have fast fingers tonight. I appreciate that. $289.75. How much of Roger's payments in the first month goes towards reducing the balance? So remember, his payment was $549.73. $549.73. And the interest was $289.75. So how much went towards reducing the balance? Subtract those, $259.98. So that 97 or that 92,720 would be reduced by $259.98. So his new loan balance would be 92,720 minus that. 20 minus that is 92,460.02. Will he owe as much in interest the next month? What do you think of that one? Will he owe as much in interest the next month? And the answer is no, because his balance decreases, right? Okay, so this wants us to calculate this loan. I know we're running out of time. Let me see. Oh, I probably have time if I put this in Excel. So let me do that in Excel. Let's see. We have to start a new table here. Month one. Oops. So we'll just do it for a couple of months. 92,720 is that beginning balance. And let's see what else this wants us to do. It wants us the monthly interest, the mortgage payment. So this is balance, monthly interest, payment, and probably new balance, right? The decreased mortgage balance. Oh, the decrease. Okay. Okay, so the monthly interest, we're going to do a formula 0.0375 divided by 12 times the previous balance, right? Oopsie, something's not right there. Oh, 0.0375. Okay. The payment is going to be constant, $549.73. All right, that's fixed. And then the decrease is going to be equals the payment minus the interest. So that's the amount of decrease. And then the new balance is going to be equals the old balance minus the decrease. And then we can just copy these down. And you can see, and of course we want these to be, we want those to be dollars, everything in dollars, so that it gives us those 2 decimal point place. All right, how does that look? Does it look good? All right, so again, you can go back and look at the formulas I put in here, so you can find out where these numbers came from again. Okay, so there's the formula big, and oops, I just screwed it up. There's the formula again for that one. Notice how the formula changes a little bit. Okay. All right, so let's get back to, whoops, we don't want to do that. There we go. Let's talk about car loans. So we are on page 142, and I'm sorry that we didn't get to do any group stuff today. It just is so much. Next week we only have one section to do, section 12, I think, maybe. I don't remember. Oh, yes. Next week is section 12, and then talking about project 2. I think that it'll go well, and we'll have time to do group work. So Let's move on to page 142. It says Excel's PMT function can also be payment amount for car loans and credit loans. And so here's some examples. Andrea's car has broken down for the third time this month, and she has decided to buy a different car. Her dream car, a 2016 Chevy Camaro. It costs $38,000. She has a $4,000 down payment set in the bank of 3% on a 60-month loan for the car. How much will Andrea need to borrow to buy the Camaro? Oh, so I see your question, Kendra. Uh-oh. Can you hear me okay? Can you hear me okay? Okay. So Kendra's question was, if you look at this Excel sheet, the last column asks for the decrease in the mortgage amount. So it's not asking for the new balance. It's asking for how much was the decrease. That's why we just take the payment minus the interest. Yeah, sometimes the wording is an issue in the book. I do agree. All right, so how much will Andrea need to borrow? $38,000 minus her down payment of $4,000. So she'll have to borrow, it looks like $34,000. And then what would Andrea need to type in Excel to figure her monthly payment? Well, equals PMT. And it says there's a table at the end of this section that'll tell you what her payment's going to be, so you don't have to actually have Excel for this example. So it's going to be the interest rate as a decimal, 0.03, divided by 12, comma, 60 payments, right? 60 months, don't forget that equals sign right there, comma, and then negative 34,000. And then if you look over on page, let's see if we can find this little table. It's on page 146. Let's see if we can find that on there. It looks like it's the first one. So her payment is going to be $610.94. And if we put that into Excel, we would get that value. So it says, what will the total of all Andrea's payments be over the lifetime of the loan? So we're going to take 60 payments times that 610.94, and she'll pay $36,000. 656, so 36,656 and 40 cents. Plus the $4,000 down payment, don't forget, right? So she's actually paying $40,000 for this car. How much will Andrea pay in interest over the lifetime of the car loan? So we can take the 36,656.40, 656.40, and subtract the amount that she borrowed, 34,000, and see that she is going to pay $2,656.40 in interest. All right, so the other thing we have is a present value and another Excel function. So this is a little bit different. And the present value function, it says here, let's assume that Brian and Julie choose a 30-year fixed mortgage rate at $425. We know that Brian and Julie can afford a monthly payment of $875. Excel uses this information in what is called the present value function to calculate the mortgage value their monthly payment would finance. So this is different than the PMT function. The PMT function is, how much will my monthly payment be? The PV function is, if I know how much I can afford each month, how much house can I buy? So the PV function, it says, so for Brian and Julie, it's the interest rate divided by 12, the number of payments, 30 years times 12 months, and then that negative $875. So their monthly payment is going to be $875. We're going to find out how much house they can afford. So if we put that into Excel, and I can do that for you so you can actually see it happen. So equals PV, and then the interest rate was 0.0425 divided by 12. 30 years times 12 payments, and they're paying $875 as their payment. So that's what it looks like. And then there's how much house they could buy. Now remember, this doesn't have the taxes and insurance in it either, okay? So it's probably a little bit high. So then it asks us, the next question says, what if they have this rate of 3.5% for 15 years? So I'm just going to put that in here. So 3.5%, 0.035 for 15 years. And are they keeping their payment the same? Yep, so they're going to keep their payment the same. And let's see how much they could get. So they're going to do a 15-year loan at 3.5%. They could buy a house of $122,000 instead of the previous $177,000. So taking down the term of the loan and keeping the payment the same caused the house to be a little bit less, $122,397.73. So it says, how much will they pay in interest on the 15-year mortgage? Well, let's figure that out. 12 payments, 15 years, $875. So this is how much they're going to pay altogether. $157,500. And their amount for the mortgage is $122,397. So let's see, minus the amount that they're borrowing, $122,397.73. So again, this $157,500 came from 12 payments, 15 years of payments of $875. That's for that. So that's how much they paid total. The amount they're borrowing is what we figured up here in this part. So the interest is the difference between the two, $35,102.27. And then how much will they pay over the 30-year mortgage? Well, that's 12 payments times 30 years times $875. And that is $315,000. And that one they're borrowing $177,000, so minus $177,000, $867.26, and then subtracting those, $137,000, $132,000, 74, yeah. So notice that 30-year mortgage is costing them an extra $137,000, where whoops, I missed a number in here. This should be $35,102.27, where the 15-year mortgage, they're only paying $35,000 in interest on that house. So they're paying almost double for the house on a 30-year mortgage. Please note that. All right, last question. Brian's best friend Cliff is house hunting as well. He is currently paying $935 in rent and would rather be spending that amount on a mortgage. If we were to choose a 30-year, 4.25, how much could he afford? So let's just put that in Excel. 30 years, 4.25. So equals PV 0.0425. That's 4.25 divided by 12. We want the monthly interest, comma, 30 years, so 30 times 12 months, comma, and then I have to look again. It was $935, so negative $935. So his friend Cliff could afford a house for $190,000. And again, remember that that's without the taxes and insurance. Whoops, let me try that again. $190, $63.87. So hopefully that made some sense. And if you need to go back and review the Excel, that's a 7 there. If you need to go back and review how I put that in Excel, please do that, okay?